Professional.
Okay, here we go. Quick. This should just take a second for you guys. There's not a lot to add to this. Parallel lines and transversals. Okay, we already know corresponding angles postulate, no big deal. If two parallel lines are cut by a transversal, then corresponding angles are congruent. So there it is. Okay, we already know all the other stuff too. We know that springing from this, we've got the alternate interior angles theorem, right? So we also know that alternate interior angles are congruent if two parallel lines are cut by a transversal. So for example, angles 1 and 2 are congruent there. Okay, we also, and I'm not going to prove any of these. We went through this proof earlier anyway, last week. So if you want to look at it, this PowerPoint will be up on the side. If you want to see this proof, you can. I'm just going to zip through that. We know the consecutive interior angles theorem. Right, we know the alternate, this isn't technically one of them, but we should include it because it works. The alternate exterior angles theorem, we know that. Right, this is all stuff that we already talked about. Okay, we know some other theorems too, the perpendicular transversal theorem. Did we get to that one?
Yeah.
Maybe we didn't talk about this one. I can't remember if we did or not, but we'll take a quick look at this one. If a transversal is perpendicular to one of two parallel lines, so if for example, we know that transversal T is perpendicular to line L, and we know that line L is parallel to line M, then what do we have to know from that?
Line T is perpendicular.
Yeah, then we also know that the transversal must be perpendicular to the other line, right? And that's easy to prove, and I'll probably have you prove that at some point. So we know that one, we know, we'll skip the proof, I'm gonna have you guys do the proof, so don't look. Cheat. I'll have you write this one up later. Here's the one I wanted to maybe have you take a quick look at. This is not a hard problem. I'll give you some harder ones later. But just the idea that it's an algebraic problem. So if I wanted you, let's just talk about how we could do this. How would I find the measure of angle 1? Yeah, just all I've got to do is subtract 125 from 180, right? Because I see that I don't even need this other line for that one, do I? Right? So that's just a linear pair. That's no big deal. Okay, angle 2, don't even need the other one, right? No big deal. Angle 3, also don't need the other line. What about angle 4? It's the same, right? Because we're told that these two lines are parallel, and what kind of angles are those? Corresponding, and so they must be congruent, right? And then we could find 5, same way, right? Is 5 related directly to 125?
No.
It's not, is it? It's not related directly, but there's any number of different routes we could take in 2 steps to relate those. We could, for example, what if I chose to say, okay, I know angle 2 is 125 by vertical angles, then how would 2 and 5 be related? Supplementary, good, because they are, no,
Corresponding or consecutive.
consecutive interior, or sometimes people say same side, but this book says consecutive. Those are interchangeable, same side interior or consecutive interior. What if we wanted to solve for x? Is this angle related directly to 125? What's the relationship? They're supplementary, aren't they? Okay, that's a weird one. These would be consecutive exterior, wouldn't they? Which is not technically one of the ones that we looked at. But it works. It'd be fine. And if we didn't, if we wanted to join them in some other way, I could say, okay, well, maybe even like 125 and angle 4 are consecutive, right? So I know that this must be 125, and then these two are supplementary by linear pair, right? But I've just got to set up some relationship and then solve for x. So what would the equation be to solve for x? Yeah, okay, good. X plus 15 plus 125 equals 180 because they're supplementary. And then just solve for x. No big deal. Like I say, that's a really easy one. I'll find some harder ways to maybe challenge you on the algebra, but you get the idea. Okay, so let me just get through all this stuff. Okay, proving lines parallel. Now, this is something I just want to point out to you. There's like two versions of each of those postulates and theorems that we talked about. I want you to think back to the ones we just went through real quickly. We went through the corresponding angles postulate first, and then we did the alternate interiors angles theorem, alternate exterior angles theorem, et cetera, et cetera. What they all had in common was the hypothesis for all of those was what? Okay, good. If two parallel lines are cut by a transversal, then various things are true. Various conclusions are true based on whichever one we're talking about, right? Okay, but the assumption was always that the two lines are parallel, and therefore we have these specific angle relationships. Okay, the other way we can do this is we can reverse that whole process. We can do the converses of all of those relationships we just talked about, and then we're flipping around the hypothesis and conclusion. Now we're making the assumption, for example, in the corresponding angles converse, which is a postulate, we're making the assumption that if two parallel lines are cut by a transversal so that corresponding angles are congruent, what must be true about those lines then? They must be parallel. So we're proving parallelism with the converses. We're not assuming parallelism. We're assuming, we're told in the given that we've got this angle relationship, and then we're going to exploit that angle relationship to say, okay, well, if that angle relationship exists, then the lines must be parallel. So we're proving them to be parallel. Other direction, right? So, and it works for all of them, right? If two lines are cut by a transversal so that blah, 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 notice the conclusion is always the same. Then the lines are parallel. Then the lines are parallel. It's like a broken record. Then the lines are parallel, right? Okay, so no big deal. You're going to do some proofs using, going both directions. You're going to do some proofs where you're told the lines are parallel, and you're going to do some where you're proving the lines are parallel. Not a big deal. What I want to maybe jump up to, we'll look at some specific proofs later, but for now I want you to just look at some stuff like this real quick. This is the kind of algebra question, a simple version of the kinds of algebra questions that you'll be doing. So say we want to choose the value of x here so that these two lines, which evidently aren't labeled here, but they're j and k, I guess, so that lines j and k are parallel to each other. Okay, what's my thinking on this one? What must the relationship be between those two angles if the lines are going to be parallel?
Yeah.
Say it again. Oh.
Supplementary.
They have to be supplementary, don't they? Because they are consecutive interior angles. And so we would know that we've got to make their sum equal to 180, which gives us an equation, which allows us to solve for x. And by solving for x, that's really identical to setting the value of x, isn't it? Right? Because what do we really do? We're just really asking the question, okay, well, if x is our unknown, this is the equation that has to be true. And so by solving for x, we're picking that value of x that makes the equation work, right? No biggie. I think we can skip this stuff. I'm just kind of anxious to maybe get you working on this. Okay, this is one more good one, yeah. Okay, just try this real quick. Decide which rays are parallel. And don't let's make any assumptions about the drawing, right? The drawing may not be to scale. Avery.
Is there an imaginary line between A, B, C, and D?
Between A, B, there doesn't need to be.
Okay.
Yeah. What do you think? Jessica, what do you think? Is EB parallel to HD? It's not, you're right. How come? What two angles would have to be congruent for that to be the case? The easier way to ask that, what are the measures of the angles that would need to be the same? If these two were going to be parallel, here, maybe this will help. Let me draw in. So if that were going to be parallel to that one, and here's a hint I'll give you. Sometimes it's really helpful when you're dealing with questions like this, where maybe they're rays, maybe they're not lines, at least in your mind, and maybe on paper, sometimes it's helpful to go ahead and extend the lines so they really do look like lines and transversals. So if I were to extend this line back that way, it would look like that, wouldn't it? And this one would look like that. And then I've got these two pink lines and this blue transversal. Does that make it a little easier? That's pretty bad. Does that make it a little easier to see? So what are the angles, anybody, that would have to be congruent here? What do you think? Yeah.
58 and 61.
Yeah, okay, because those are what kinds of angles relative to the pink lines and the transversal? Corresponding, yeah. So corresponding angles would have to be congruent, and they are not, right? Does that make sense? Does this strategy make sense? Is that okay to do? If they're giving me a problem in which these are rays, is it okay to think about the problem in terms of lines instead?
Yeah.
Sure, right? Because rays are contained within lines, aren't they? Anything that's true for that ray should be true for its extension, which is a line in this situation. Does that make sense? Okay, so we know that this answer is no. No, because those two angles are not congruent, right? Okay, what about the other one then? Is EA parallel to HC?
Yeah.
Yeah, it is. A couple ways we can, well, how did you do that, Jill? What was your thinking?
I added the 58 and 62 together, and then I made a whatever that little angle. I made that.
This
X.
one right here?
Yeah.
Okay.
X.
Uh-huh.
And so you do 58 plus 62 is something.
What is that?
120.
120.
And then you do 180 minus 120 is
Okay.
60, and that's the measure of that. And then
Okay.
you do that to the same side.
Okay, same thing over here. 59 and 61 are 120. So this must also be 60. And so, yeah, it works for those, doesn't it? Because then the corresponding angles are congruent. Good. We could have found, it's kind of convenient to find this one because it's a small angle and it's not so messy, but you also could have, I guess, just said, well, we don't need that one. We could even just do that one's 120 and that one's 120. And so those two are corresponding angles, even though they're obtuse. Okay, either way, but you're right. So this one, these are parallel. Good. Okay, we already went through this. Okay, so in summary, real quick, and this is where we'll just leave this, and then you can work. Two lines are cut by a transversal. How can you tell? How can you prove the lines are parallel? Any one of those converses works, right? Any one of them. Doesn't matter. All it takes is one, and you prove that they're parallel. Questions? That was quick, but I think that's enough for you guys. All right.